And welcome to today's lesson. I'm so glad to have you even today. This is your friend and teacher, Kaunga Samuel. To those of you who are new to this channel, really, I'm so glad to host you on my channel today. Please, if what you're going to watch here is going to be pleasing unto you, consider subscribing. Right. Without wasting much of our time, this is going to be an interesting lesson. Please stay with me until the end of the video. If you're in grade 10, you're in grade 11, you're in grade 12, this is a lesson. This is a place for you to be. This is your lesson. Especially those of you who are in grade 12, you are trying to prepare for exams. You are in grade 12, you're preparing for exams. Second theorem, you're going to meet it in your grade 12 paper 1. All right. This is with respect to the Zambian syllabus. So straight away, let's just jump into the theorems and see how we can work around the theorems. Okay, theorem 1 is just before your screen here. The angle at the center is twice the angle at the circumference. Here, I'll just be giving you distinct interpretations. So that simply means the angle at the center is two times the angle at the circumference. That simply means if this is your circle, okay? By the way, what is important for you to note under circle theorems, it is to relate. Please try to relate, okay? Here, I want you to begin to relate each theorem to its diagram, or circle. Okay, you need to be able to do that. So if you can relate each theorem, you need to study the diagram, okay, and see how it is presented to you. All right, so straight away, let's just look at theorem 1. So theorem 1, the angle at the center is twice the angle at the circumference. So what this simply means, okay, in theorem 1, that simply means, let me just show you, if this angle here is, if my angle there is 100 degrees, then the angle at the circumference here is going to be 50 degrees. That is what this means. Okay, that is the meaning there. The angle at the center is two times that angle which is going to lie at the circumference. Okay, if this is your circle, okay, the circumference is this distance around the circle there. That is our circumference. Okay, straight, let's jump into theorem number 2, okay, without wasting much of our time. Theorem number 2. So for theorem 2 here, we're going to look at this theorem there. So for this theorem, we're simply saying an angle in a semicircle is always a right angle. An angle in a semicircle is always a right angle. What that simply means is that, okay, if, let me just try to draw a circle there, okay. If that is my circle, okay, if that is my circle there, okay, so what that simply means is that what that means is this here. If this is the middle of the circle, okay, so let's just call this as the circle. So you discover that any triangle that is going to be, okay, that is going to lie, for example, let's have some lines there. If I have a triangle like that, then coming there, okay, this triangle here at the circumference, I'm going to have 90 degrees always. So you need to look out for this kind of working there. Very, very important. Okay, straight, let's jump into theorem number 3. Theorem number 3. So for theorem number 3 now, we are simply going to say, okay, theorem 3, opposite angles of a cyclic quadrilateral add up to 180 degrees. What is a cyclic quad? So a cyclic quad is a quad whose, let me just draw this circle here so that you can see, we can really understand what we mean by cyclic quad. If that is my circle there, okay, so a cyclic quad is going to touch is a four-sided shape, a cyclic quad. So we're looking at a four-sided shape, a four-sided, a four-sided shape whose whose corners whose corners touches the circumference of the circle is known as a cyclic quad there. So that is going to be called a cyclic quadrilateral. Okay, that is the meaning there. That is what we're going to call a cyclic quad. Okay, so let's have any four-sided shape there. So I can have this 1, 2, 3, and 4 there. So you can see that if this is my A, this is my B, this is my C, and this is my D. So what that simply means is that A plus D will always be 180 degrees, as well as C plus B will always be 180 degrees. That's the meaning there. As simple as that. So your duty is just to study. In this question, do I have a cyclic quad? Look out for a cyclic quad. If you can spot one, then it will simplify your work. Straight away, let's jump into theorem number 4, okay, for today. So this is going to be part 1. We're going to return for part 2. In part 2, I'll be looking at tangents. So look out for that lesson where we will be dealing with tangents, okay, and alternate segment theorem. So that is going to be in part 2. In this, we are just going to look at the first 4 theorems. So let's continue with this journey. If you are liking this video so far, give it a thumbs up. So let's look at the last theorem for today, okay. So the last theorem for today is that angles from the same arc in the same segment are equal. Okay, so what that simply means is that we're going to utilize this tool so much. Okay, so what that simply means is that, okay, is that if this is my circle there, okay, if that is my circle, so in this circle I want you to take note that this is going to be called, let me use a brighter color there, this is going to be called an arc. Okay, sorry, so this red thing here, we're going to call it an arc. Okay, a part of a circumference, that's an arc. Okay, a part of a circumference is what we're going to say an arc. All right, so now you discover that, okay, here if we have a line, okay, this here we're going to call it we're going to call this as a minor segment. This here is going to be called a major segment. A major segment. So you discover that angles that are going to be in the same segment, angles in the same segment, okay, standing. So from, if like it is here A, if my A is here and my B is here, this is going to be my arc. Okay, this here is going to be my major arc, then this one is going to be my minor arc. Okay, minor arc, this is minor arc, then this is going to be my major arc. All right, very, very important for you to understand this concept here. So the angles that are going to be in the same segment, they're going to be equal. Angles from the same arc, okay, these angles are standing on the same arc. As you can see here, these angles, all right, if my angles are like this, they're standing on this arc here, okay. Angles that are going to stand on that there. Okay, so you can see that these angles are standing, okay, on this arc AB, on arc AB. The angles at the circumference, and they're in the same segment. They're in the same segment. These angles are in the same segment, this major segment there. At the circumference, this angle and that angle, they are going to be equal. These angles are standing on this arc there, arc AB, arc AB. Okay, but they're sitting where? In the major segment. This is the major segment there. Okay, the minor segment is just under this black line there. Right, let me just clear this annotation so that we are able to see things clearly. Straight away, let's just go into questions. Okay, into questions. Please remember, attach theorems, okay, to each diagram. Right? Straight away, let's just look at examples. Okay, they are questions, but we'll save them as examples. Okay, let's look at exercise 1, second theorem, exercise 1. Okay, I'll do that. Second theorem, exercise 1. So what we're going to do is to answer, maybe to just answer these questions. Okay, now the question says, find the value of the letters in each of the following diagrams. So here we've got x, y, x, y, x, y. So let us just jump into this solution and see how we can answer certain questions. Okay, so what we're going to do is to answer certain questions here. Okay, we can even use space there. Let's answer question 1. Question number 1. So for question number 1, I want you to just pay particular attention. So for question 1, we are simply saying this, when you look at it with critical eyes, you are going to discover that this is a cyclic quad. It touches the circle there and there and there and there. So the opposite angles of a cyclic quad are always adding up to 180 degrees. So what that simply means is that I'll simply say, right, I'm going to say, okay, for the second one, for the first one, I'm simply going to say x plus 130 degrees should give me 180 degrees. So therefore, x is going to give me 180 degrees less 130 degrees, which is now going to give me x is equal to 50 degrees there. X is going to be 50 degrees. 50 degrees. And that's it. Very simple indeed. Very simple indeed. That is the answer for number 1. The value for x is going to be 50 degrees. Now, when you look at number 2, we are simply saying, look at that diagram carefully. You discover that this, okay, this here is another cyclic quad. So it has this corner, this corner, this corner, and that corner touching the circumference. So we're going to say, okay, let's just discover which ones are going to be opposite sides, okay? Which ones are going to be opposite sides, and then we can work with those sides, all right? I hope you are able to see them, isn't it? Yeah, I know you are able to see them. So what we're simply going to do is to say, okay, for this one, I'll say, for question 2, I'm going to say x plus 124 degrees is going to give me 180 degrees there. Okay, so here I'm going to have x is going to give me 180 degrees less 124 degrees there. Okay, less 124 degrees there. So which is going to give me x is equal to 180 less 124. We are going to have 56 there. 56 degrees. So this angle here is 56 degrees. Okay, I'll clear this to pave way for the others. Okay, so I'll clear that. Let's pave way for y. So for y, we're simply saying I'm going to have y is opposite that, so I'm going to say y plus 80 is going to give me 180 degrees. So y is going to give me 180 degrees less 80 degrees, which is going to give me y is equal to 100 degrees. As simple as that. So for question 2, we are done. Right. That's how you work with a circle theorem. Okay. So basically, this is how, when you look at these questions, all of them, these are cyclic quads. You can apply the cyclic quadrilateral theorem to handle such questions. Let's proceed to some more questions. Let's look at example 2 questions. Okay. So let's look at exercise 2 questions and see what is there. Great. Now, when you look at these questions, okay, 7, 8, 9, okay, 10, 11. So let's just see how we can also handle these questions. Solution. Okay, I'll try to use different colors here so that we don't lose the questions. So we are going to say, okay, for this one, I'll simply say, for question 7. So for question 7, when you look at question 7 with analysis, you would discover that here I have been given that length and that length, they're the same. So this is an equilateral triangle. Rather, it's an isosceles, not equilateral. Sorry for that. This is an isosceles triangle. There is this stroke and that stroke telling you that this is isosceles. So you will discover that for this one, we are simply going to say, okay, for me to find the value of x, this is a cyclic quad. This one, it is a cyclic quad. So meaning the angle here, and the angle there should give you 180. So what we're going to do is to say, right, what we're simply doing is to say, okay, for me to get the angle here, to get the angle there, I'll simply say, let me call this angle as angle T. Okay, so I'll say angle T plus 58 degrees. Angle T plus 58 degrees. Let me start again. Angle T, okay, plus 58 degrees should give me 180 degrees. So T is now going to give me 180 less 58 degrees, okay, 180 less 58, which is going to give me 122 degrees. So this one is 122 degrees there. Okay, now since this is an isosceles triangle, so you discover that for me to find x, I'll simply subtract 122 from 180 and divide the solution by 2. So I'm going to have 58 at the end of the day. So 122, 180 less 122 is back at 58. Okay, 180 less 122, we have 58. So I'm going to say, okay, that one is going to give me, x is going to give me, therefore I'll say x is now going to give me 58 divided by 2. So my x is now going to give me 58 divided 2. We have 29 degrees. That is the solution to question number 7. I hope this is simple. I hope you are enjoying the lesson so far. Please, if this lesson is helping you, give it a thumbs up. Great. Okay, so without wasting much of our time, okay, I'll clear this. You can rewind the video. I'll clear this, okay. I'm going to clear this working, okay, so that we can also create room for some other questions. I want you to be seeing the questions, that's why I'm not moving them to a next page. Okay, let's attempt question number, which one can we attempt there? Okay, let's attempt question number 10. Okay, for question number 10, you will discover that x is simply going to be 50 there. You will discover that these angles are coming, okay, they're originating there, or they are standing on this, on that chord there, okay. So they are standing on that, and they are on the same arc, on the same arc. So the angle at the circumference, this angle and that angle, they are going to be the same. Very simple indeed. So for question 10, x is simply going to give me 50 degrees, and you are done. That is your solution. These are angles in the same segment, angles in the same segment. So we are simply saying these are same segment angles, same segment angles, okay. Next, I clear this. You can rewind the video. Let's just look at question number, maybe question number 12. Question number 12, this one here. So for question 12, we're simply saying this one, okay, x is the same as 54. So for x, we have 54. X is going to be 54 degrees. These are same segment angles, angles in the same segment. Now, what would be the value for y? Now, you will discover that the value for y is very simple to find. Here, you can either go this way or that way. Look at this. This here is going to give you a cyclic quad. Can you see that? Cyclic quad. Or if you go that way, this is going to give you a cyclic quad. All right, a cyclic quad. That simply means y is equal to, so y is equal to 180 degrees minus 54 degrees. That is going to be the value for angle y there on question number 12, 180 less 54. What we are going to have is 126. So y is equal to 126 degrees. All right, that's how you handle second theorem challenges. Very simple indeed. Okay, lastly, let's look at, for this exercise, I'll clear this. Please, you can rewind the video and really check to make sure that the answers are correct. So maybe let's look at question number 9. So for question number 9, this is an interesting question, very simple indeed. So you discover that for question number 9, what we are going to have is this, okay. Look, this is a cyclic quad. I hope you can see that. It has got how many corners? 1, 2, 3, 4 corners, all the 4 corners touching the circumference of the circle. So this makes it a cyclic quad, but it is so interesting in that it has got 2 isosceles triangles in it. So you discover that, okay, for you to find the value of x and y, first of all, we're going to use the upper triangle, this upper triangle there, this upper isosceles triangle here, this upper isosceles triangle, that is going to start with. So what we're going to do is to say, right, one is to say, okay, 180. So I'm going to say x is equal to, so x is going to give me 180 minus 24, okay, degrees. The result divided by 2, because I'm going to have 2 angles there. So we are simply saying 180, okay, less 24 is 156. So 156 there divided by 2. So 156 divided by 2, what we're going to have is 78. So x is going to be 78 degrees. So x is 78 degrees. That is your value for x. So let me just clear this, okay. So x is 78 degrees. So this value here is going to give us 78 degrees. This is 78 degrees as the value for x. Okay, now you discover that this angle here and this angle there, they are opposite, they are facing each other. So they are facing each other. So what we're going to do is to simply say, okay, x plus y is going to give me 180. So we are simply saying y is going to give me 180 less 78 there, okay, 180 less 78, okay. So this one y is going to give me, so angle y is simply going to give me y is equal to 180 less 78. So this is going to give me 180 less 78. We are going to have, let me just clear this, we write it nicely. so 78 degrees. So this is going to give me 102 degrees as my value for y in that diagram. That's how you handle second theorem challenges. Very, very simple indeed. Straight to the point. You can't really go wrong if you understand how to relate each theorem to its question. Okay, very, very simple indeed. So I hope this has added value to your lessons or to your studies. Maybe let me just look at one last exercise. Okay, so let's look at exercise 3. Okay, so for exercise 3, this is what we're going to look at. Okay, now look at that. This is related to the angle in a semicircle. The angle in a semicircle. So let's just jump into question 13 and see how we can answer this one. So this one is going to say, okay, for question 13, look at it nicely. So here, y and 106, these are angles, okay, on a straight line. So for me to find that, I'll simply say, okay, y on a straight line. So I'll simply say y is going to give me 180 minus 106 degrees. So y is now going to give me 180 less 106. So I'm going to have my y as 74 degrees. That is my value for y. So y is equal to 74 degrees. 74 degrees. And what will be my value for x? So my value for x, remember, this here is a semicircle. So a triangle, okay, which is in a semicircle, all right, at the circumference, it will give you a 90 degrees. So there is 90 degrees there. You should not forget that concept. So meaning that for me to get x, I'll simply say, okay, x is now going to give me, x is equal to 180 minus 90 plus 74 degrees. That is going to be my value for x. So x is simply going to say, okay, 180 less 90 less 74 degrees. So we're going to have x as equal to, so x is going to give us the value of 16 degrees. Okay, 16 degrees. That is going to be your value for x. So this is for question number 13 there. So for question 13, we have our x is y, x is equal to 16, y is equal to 74. So x is equal to 16 degrees, comma, y is equal to 74 degrees. So this is for this question there. All right. So this video has been long. Okay, let me not bore you. So let's just look at one last question there, and then the rest can be a practice for you. Okay, let's look at question number 17. So interesting there. Question 17 is so interesting. So let's just look at it as the closing question. So for question 17, you would discover that angles at this for x, we're simply saying x is going to be 2 by 44. So for x, we're going to say x is going to give us so let's just work it right here where it is. So here we're simply saying x is equal to 2 times 44 degrees. So x is going to give me 2 times 44. We have 88 degrees. This is the angle for x. Now for y, you would discover that, okay, this is the radius. I want you to understand from there to there, this is the radius, as well as from there to there to there, that's the radius. So what do I have? I now have my isosceles triangle. So this and that is forming an isosceles triangle. So if that is an isosceles triangle, what can we say about y? So for me to get y, I'll simply say y is going to give me 180 less 88 degrees, the result divided by 2. So we're simply saying 180 less 88 is 92, divided by 2 we are going to get y is equal to, so y is equal to 46 degrees. All right. This has been circle theorem. Please, if this has helped you to understand one or two things, consider liking the video and sharing it to as many groups as possible. Really, in the next lesson, we will be looking at angles to do with tangents. Okay, tangents. From me, it's goodbye.